right, so the learning target for today and the last part of this lesson is to explore the relationship between the symmetry or skewness of a graph. What does symmetry mean? You should know that word. Symmetrical on both sides. Yes, it's folded in half, okay? Does anybody know what skewness of a graph means in this period? Not mixed up. Anybody else? Try again.
More on one side than the other.
Yes, thank you, Andrew. More on one side than the other. So, if I were to stand right here in the classroom, what side has the skewness? This side. It's more congested, right? Way more on this side, okay? So, let's get started with our notes. So, we're going to be looking at how the shape and the center of a graph changes when we change the data values. So, this is the data of foot length for 40 high school students. And the first part says create a histogram for the data with bin widths of what? 4. So, how are you going to do this?
Multiplication and division of 4.
No, how are you going to create a histogram?
Graph.
All right, come on, start typing. All right, to get a histogram on your Desmos after you've typed your data set in is you type the word histogram, parentheses, and then the letter that you used for your list. Now, this histogram, when you first look at it, it looks like the little city line, remember? And we talked about this last week. Is this a good histogram to plot? No. What did our notes say to change the bin width to? 4. So if you don't know how to do it, watch. You click here where it says 1. It opens up the parentheses and delete the 1. Put 4. Now is it better? Yes. Did I do that? Yeah, that's not right. The wrong Desmos. Oh, sorry. I'm not Texas proud right now. Okay, so I didn't type it wrong. I had it aligned to the center, and I'm supposed to align it to the what?
Left.
To the left. So everybody's histogram should look like this. Are we good?
Wait, what's the bin width? What's the bin width?
Bin width is 4. I showed you how to change the bin width. Okay?
Minus the bin. Yeah, bin.
Mine's taller? It's probably, yeah, it's by my grid.
Mine is like a really long middle thing.
Mine like has a really long the middle's like super long.
Yeah, 9-3. Yours looks more wide.
Okay. All right, based on the way it looks, would you say that it's relatively symmetric?
Yes.
Yes, relatively symmetric. Write that down. And then, does it have a longer tail on one side than the other?
I think on the right.
No.
They're equal.
They're equal. They're symmetric. Yeah.
Okay.
Okay, so let's sketch the bins just really quickly. Doesn't have to be perfect. The only difference is that on our grid, they're timed by 2. So pay attention to that. So if our bin width is 4, what should it be on ours? 2 units, okay? So the first range is from 16 to what? No. 20. And how high is the frequency? 1. So if this is 2 and we're going to go all the way to the line, it's halfway. So 10, 12, 14, 16 to 20. So it looks like this. And that's 1, right?
I just think the bin width on that one.
And the next one is from 20 to 24. And how high is that frequency? 6. Good. All right. Next one is the tallest one. I'll pause it. Okay. Not 22. Zoom in on your Desmos. How high does it go up? 23, thank you. Okay. All right. And then the next range is from 28 to 32. It should also be 6, right? Make sure you're counting 2 squares. And then the next one is from 32 to 36, and it should be 4. Okay. All right, part B says create a box plot for the data. Compare the box plot to the histogram. What do you notice? So we already have the data on Desmos. Now we just need to command Desmos to give us a what?
Box one.
Box plot. Okay, do that really quickly and sketch it.
That's sometimes into that one.
All right, did you input box plot to Desmos? All right, based on the box plot, what's the minimum? Good. What's Q1, the first part? 24, good. The median? 26, good. And Q3?
27.5.
Good, 27.5. And what's the max? Technically, it's not 32. What is it? 35. But on the box plot, we only go up to 32, right?
Why?
Yeah, why?
You don't have the answer?
We excluded the outliers, but if you unclick exclude,
So
it'll
why
show
are
you
we,
them.
why are we?
Because sometimes it's good to see which part of the data is like off. Like you're way off from everyone here.
Oh.
That's a good question. Why do we exclude them? So unclick it and include them, and you can see the line go all the way to the 35, right?
Because they're further away, we're gonna.
Yes. Where like most of our data is right here.
And that's the only thing that matters.
Yeah. Sometimes depends what you're looking at. We're looking at foot length, so I would be like, dang, your foot is way bigger than everybody else. Whoa.
Oh.
But you'd be excluded.
Yeah.
But you still have to change the max. Compared to how it
Technically, the max is this 35. You can't change that
Yeah.
because it's part of the data.
Even if it tells
The excluding is just for the picture, for the box plot.
Okay.
Yes. So when we draw a box plot, just sketch it really quick. The minimum is 19, so that's about right here. The Q1 is 24, so 20, 23, 24 right here. The median is pretty close to it, 26. Okay. And then the Q3 is 27.5, so it's right. This is the median. And then our max is 32. Right there. Okay? It doesn't look pretty, but just sketch it, okay? Alright, now the question is compare the box plot with the histogram. What do you notice? Anybody have any ideas? Looking at both of them on top of each other. What do you notice? Yeah, comparing this and this. What's similar? What's different? It should be similar. What's similar about it? Does anybody remember what we call the actual box here in the middle? Interquartile range. So, the interquartile range, good job, Evan, is relatively in the same area as what? The highest bar, yeah, the highest bin. Okay, good job. All right, let's go to part C. Calculate the mean and the median of the data. Who can calculate that for you? Desmos. So go ahead and type. What's the mean?
The mean is 26.05.
Good. 26.05. Write it down. And the median, we already have it, right? What's the median?
Big back one.
26.
26. Okay. All right. Write it down. Now the question is saying, draw vertical lines on the histogram for the mean and the median, and label each one. So you have to remember what variable draws those vertical lines on our graphs in eGrid from Algebra 1. X equals. So if you don't remember that, draw a little note here off to the side. When you're drawing vertical lines, they look like this, X equals. And so they want us to draw the vertical lines for these numbers, okay? So if you like to use two colors, that's why I did two different colors so we can see the difference. But before we draw the vertical lines, what do you know about these two numbers? they're very close, right? 26 is very close to 26.05. So when you're drawing it, just make sure you label both, okay? So vertical line at 26 is right here. That is the median. Okay, if you want to use a straight edge, use your ID. So you should be wearing it. To draw your vertical line. Good. And then median is right next to it at 26.05. That is the median. So I switched colors so I can see both, okay? Alright. Again, this was at 26.0. Okay? Alright, when you're done, please turn to the back page because now we're going to change the data. That was the whole point of this. Change the shape of the data. Okay, so how are we going to change this? What are they saying? What does it say? Suppose what?
6 with the smallest feet were no longer included.
Okay, so we're going to get rid of all the people with the smallest feet. And what are we going to do? The students with the largest feet were included instead. Okay, so we're going to replace the smallest centimeters with what?
Biggest.
With the biggest feet. Okay, and they're going to be these lengths right here. So before you get confused, you're not deleting all 40 students. You're only deleting who? The 6 smallest feet. And we're going to replace those 6 smallest measures with 37, 38, 38, 39, 40, and 40. Now, I already did the homework for you, so I'm going to tell you what are the smallest 6 measurements. Ready? So you're replacing the smallest values, which are replace 19, 20, another 20, 22, another 22, and a 23.
Wait, let me check that.
So anytime when you see these 6 numbers, you're going to replace them with what? With the ones they gave us here. So in your data entries, everyone's going back to Desmos. You gotta be careful. Look for 19. When you see 19, what are you gonna replace it with? 37. Now that doesn't mean all the 19s have to be 37. That just means one of them needs to be 37. Change it. Okay. Then do 2 of the 20s need to be 38. Okay. Now this is when it gets confusing. The 22 needs to be replaced with 40. The other 22 needs to be replaced with, 39 and 40, and then 23 with a 40. Okay? So very slowly and carefully, don't do what I did and mess it up. Replace the numbers, and then we're going to see what changed. Okay, here is the histogram now that I replaced the smallest 6 values and replaced them with some big values in the data. Okay? So what do you notice about the graph? How did it change from the front? The front one we did that was super symmetric. How did it change?
Okay.
Good. Thank you for using your vocabulary. There's a skew on what side?
The right side.
The right side. Okay? And so we're going to draw this sketch on our... Actually, let's answer that here first. Is it symmetric? No, not symmetric. Not this one. Okay? And does it have a longer tail on one side than on the other?
Yeah.
Yes. This is actually a right skewed graph. Histogram. Okay. So if you didn't know the word skew, now you know how we use it in statistics. Okay. And we're going to keep looking at that. Okay. All right. When you sketch the histogram, we're gonna start from 20 and go to 24. So everybody follow along. The first one is only a one, step one, so go halfway. 20 to 24 is the first bin. Everybody got that? From 24 to 28, we're gonna go all the way up to 23 again. So 20, 22, 23 is right there in the middle. Okay. The next range from 28 to 32, what frequency is that one? It's the third bin. Anybody? 6, good job. Is that what you said? Alright, yeah, 6. Alright, from 32 to 36 is 4, good. So that's 2 little unit squares, because we're counting by 2. And then the next one? 4 again. And then from 40 to 42, to 44, sorry. 2. Okay? Alright, now logically, does that make sense that since we replaced the smallest values and put big values, does that make sense that the graph is now skewed to the right?
Yeah.
Yes. Okay. So on Desmos, you're gonna create your box plot, but to save time, I'm just gonna give you the 5 important numbers, unless somebody already has them. Anybody have them?
Wait, what are the back part numbers? The mean thing?
Minimum, Q1, median, Q3, and max. Good. 23 is the minimum. What's Q1?
Q1 25.
25 exactly?
Yeah.
Okay, good. Median?
27.
27, good.
Q3 31.
Q3 is 31. What was max? 40, good job.
Yeah.
Alright, do you feel confident that you have all these 5 numbers, you can sketch your box plot later? Yes? So this would be your minimum, it'll go up to your Q1, then your median, then your Q3, and then your max. Yes?
Yeah, that's the right number.
Okay. Alright, let's move on to, you're gonna sketch that on your own. Don't do it like vertically like I do. I'm just giving you attention. Alright, let's do part C. Okay, calculate the mean and the median. So I'm gonna use 2 colors because remember we have to draw the vertical line. So what was the mean? Who can give you the mean to the fact? Desmond, can you tell me what's the mean? Good. Don't forget that if I allow you to use Desmond, please use it. And this is the time to use it. What's the median? We had already found out. 27. Okay. Alright, now we draw the vertical line. So 28, 27, and 27. So 20, 22, 24, 26, 27, the median. The mean is 28.7. Alright, so on your histogram you have those 2 vertical lines. Okay. So now that the histogram was not symmetric, it was skewed to the right. Were the mean and the median close in range?
No.
No, they're actually a whole number above, a whole step above each other. So they're not really aligned, okay? All right, let's do the back page. Okay. Now, comparing the histograms from the front and from the inside of your notes, what do you notice? Especially look at the location of the mean and the median. What do you notice?
The second one, they're further apart.
Yes. So the second histogram, let's write this down. I'm going to abbreviate, okay? The second histogram mean and median have noticeably different values. Remember on the back pages, sometimes I don't know how to spell. Noticeably different, right? Compared to the first histogram, they were very close, right? Like 0.05. Whereas the second one, it was not, it was way off of 1 point something. Okay. Now, the third one. Imagine that a histogram had so many bins at the top of the bars appeared to form a curve. In these three hypothetical data displays, one is symmetric and two are skewed. So we're looking at these three, okay? Determine which vertical lines are the mean, median, and mode of each distribution. So, clearly, for the symmetric one, the mean, median, and mode are on the same line, right? They should be close in range, okay? So kind of like we saw 26, 26.05, they should all be aligned, okay? But we did a right skew, correct? And on our histogram, where was the median? In the middle, right? Where was the mean?
On the left.
On the right. So here, median and mean. Okay, we're looking at these little lines, the vertical lines. Okay. And so what's the third one that we didn't really look at, but it's still important? Mode. Okay. So we saw both of these today. Okay. We didn't get to see a left skew, but you have a picture here, you have a graphic. So where would you put the mean for the left skew? On the left side, good. Okay, median, middle, and then mode can go here. Okay. Now another word you want to write down on here is the tail. So wherever the tail is, if you're looking at a data display, the tail is usually where the skewness is. So if the skew's on the right, the tail's on the right. If the skew's on the left, then the left is where the tail is. Okay. Now, this is a very important thing to write down because you're going to need it for your homework. For skewed distributions, write this down. This is the last thing we're writing. For skewed distributions, the median is often what? Can anybody finish that?
In the middle.
It is the middle. It's a better summary for summarizing the stats. Okay? Because that skewness is going to throw off the mean, right? Better summary statistics. Okay? And it's mainly to describe the center of distribution. So if you want to find the center, look at the median instead, okay? This is gonna go on page 15. I'm not done. Okay, so you're doing this on page 15. There's the title, Changing Shape and Center. And then Logan is passing out your homework. It is due on Wednesday next week. Don't forget there's no school Monday for you. Make sure that you look at the slides so that you understand how to answer the questions on the where you're matching. And then there's a back to it. You have to do the front and the back. Okay? All right, thank you.